Let's start by briefly summarizing your industry education and professional background.
Okay, yeah, actually, I have a mixed education background of engineering and finance. I'm holding two bachelor degrees. One is engineering and one is finance. Also have the Master of Finance degree and the CFA and the FRM charter holder with 5 years accumulative working experience in corporate finance. This is my second year in Morningstar DBRS, working as a senior credit rating analyst, covering the regulated utility and the IPP sector. I'm doing the credit rating for regulated utilities and IPP across the normally just across the North America, and also conducting some like topical industry research, such as electrification, hydrogen, and artificial intelligence in utility sector.
So what are the core primary business markets for Morningstar DBRS, and what is your role with them?
Morningstar DBRS is the world's fourth largest credit rating agency, providing the independent credit rating service for financial institutions, corporates, and sovereign entities, structured finance products, and other related financial instruments. And as I mentioned, I'm in the corporate finance team covering the regulated utility and the independent power producer sector.
Okay, our audience is typically engineers. How does Morningstar work with engineers? They help provide financing? Do they advise? Kind of how do they work with them typically?
Typically, we don't work with engineers. We work with the corporates. So usually corporates have some like finance plans, or they are going to issue some debt. We use our analytical methods to assign the proper rating to the corporate debt.
So how would you describe a virtual power plant as well as distributed energy source resources, and how do they relate to each other?
I think it is very apparent from its name, virtual power plant. VPP is not a real power plant, generation plant, which could generate power through fossil fuels or other clean energy resources. Generally, we can take virtual power plants as a kind of solution that aggregates the distributed energy resources to operate as a single power plant. VPP can also be a program that effectively manages and distributes the peak power demand through the dispatching customer-sided devices. The DER, the distribute energy resources, are usually some small generation units that are located on consumers' side. They could be your rooftop solar panels, home use battery, and some small scale wind turbines. So VPPs can aggregate these various sources of small energy resources, operate and distribute this energy like a real power plant. For example, when your like rooftop solar produce more energy than your home actually needs, VPP can collect them and feed the grid when the demand is high. So the role of VPP the role of DER to VPP is a little bit like the role of fossil fuels to traditional power generation plants. So DERs are where the energy comes from for VPPs.
Okay, so is the a VPP, is it like, is there any software involved? I get that it's several different types of distributed energy sources, but what controls and runs and directs the VPP to do what it does?
You can think that VPP is actually a platform that can just collect different source of energies, like small piece of source of energy together and distribute them as a whole. So traditional power plant is normally just centralized, like a big power plant that generate the power on one side and distributed them to different end users, right? But VPP is like a platform that can collect different source of energy together and distribute them to the end use consumers. So maybe that would be easier to understand.
No, I think it is. I guess I'm just trying to wonder what's the technology and how does it, who's making the decisions? Is there someone behind a VPP directing the traffic, or is it kind of automated through software or something like
It,
artificial intelligence?
I think usually it's just automatically designed. something that is right now happening in Canada, Ontario, is that the government is promoting a safe energy program that the homeowner can enroll into that program to give the authority to the to the I think it's ISO, yeah, to the ISO to automatically adjust their thermostatus when the temperature when the electricity demand is high. It just automatically decrease your thermostatus to maybe maximum 2 degrees, then to save some energy and to relieve the grid.
So how can VPPs impact the utility industry and help them improve sustainability goals?
As what I discussed in the commentary, VPPs could help the utility industry's energy transformation by enhancing the operational efficiency, stabilizing the energy supply and demand, and reducing the environmental footprint. Additionally, I think VPP could also help reduce the volatility of the energy price and the frequency of some unscheduled maintenance through the integration of the renewable energy sources. All of these could be some kind of credit positive for utilities industry, because the utilities operation risk can be reduced, and due to more stable and predictable electricity loads, and the grid stability will be improved, as well as the operating cost will be decreased. So it sounds like some very positive impact for the utility industry.
Okay, so are there any limitations, challenges, or drawbacks to using VPPs? So why aren't they everywhere?
VPP have some bunch of drawbacks and limitations. The first one comes to my mind is the regulations, because as we've all known that utility is usually the highly regulated industry, but the current regulatory environments were designed for traditional and centralized power systems. They may not account for unique attributes of the distribute energy resources. And the policies across different regions could be very inconsistent, which can pose complex and uncertain scenarios for VPP operators. This will make it difficult for the operator to invest with confidence in those new technologies. And the second challenging comes to my mind is the technical and operational hurdles, because integrating different range of DERs into a seamless VPP requires very complicated software and control systems that can communicate effectively with various devices. But usually different energy assets have their own operational characteristics and constraints. So it can be a very considerable challenge. And the third one is the market access and the participation. I think VPP needs the access to the electricity market to sell their service, but the current market rules may not be designed to accommodate the participation, especially when it comes to bidding and compensation mechanisms. There are also some other drawbacks, such as stakeholder coordination, customers acceptance, and the standardization of the DER technologies. And I think all of this can pose some obstacles to the widespread adoption of the VPPs.
Okay, so do you have any recommendations on how to improve some of those, particularly the inconsistencies, ways to do that, and also to improve the access for everyone?
My recommendation is that for engineer, yeah, they can just try to develop some advanced technology to design a platform that can integrate different DERs into just one single platform with general protocols that can accommodate different types of these devices. The second one is that we can promote some education to improve the customers' acceptance, to let them know the benefits for the grid, and as well as for the customer themselves to enroll in this kind of VPP programs. And this third one for utility, I think they can be more they can have more positive attitude to this kind of technology, because as you know, the utility industry tends to be very conservative. So because it's the nature of the utility industry is very stable with some deemed return from the regulator side. So they usually just reluctant to make change. So I think utility industry needs to be more positive and to be more open to embrace this kind of new technologies to help the adoption of VPPs.
Okay, so you started talking about the technologies. When you can elaborate those a little bit more, do you need like to have a full-blown digital twin to run a VPP? Are there various like levels of technology that you can get involved with to be able to create one?
Honestly, I haven't done much research about the digital twins, but I guess digital twins are not strict requirement for VPPs because uh, uh, but I think they can provide some significant advantages and benefits to for the development of VPP, because I think VPP can be developed and operated without digital twins. Basic VPP requirement, basic VPP functionality, such as aggregating and managing DRs, can be achieved with just traditional monitoring and control systems. But with digital twins, VPP can be able to provide deeper insights and enabling more precise real-time monitoring and control, and improved overall efficiency and reliability, especially as the energy grid is becoming more and more complex, and the penetration of the renewable energy is increasing. Using digital twins, such advanced tools maybe can allow for more complicated management and integration of the emerging technologies. Yeah, that's my piece of sense.
So to kind of give me a full description of how this could work, I'm hoping that you can describe like an ideal VPP system, like what it would look like, where the energy would come from. If you had, got your wish on everything, what would an ideal VPP look like? And if you could be as specific as possible, that would be great with examples.
In my perspective, an idea work plan, a picture for a successful VPP can be maybe broken down into 4 phases. The phase one is about planning and design, because in this phase, we should firstly have the initial assessment and the feasibility study, which includes identifying and evaluating the available distributed energy resources, assessing the current infrastructure, analyzing the technical, economic, and the regulatory viability of the VPP. After that, we need to confirm the stakeholder engagement, work closely with potential participants and utility companies, then design system and architectures, secure necessary permits and approvals from regulatory authorities. That's the phase one. And for phase two is all about the VBP deployment and integration. Uh, I'm not the expert of the engineering, so I'm guessing it might include maybe procurement, site preparation, system integration, and some system testing. So move to the phase three should be the VBP operation and use, which could include the developing operational protocols and the procedures for VPP management, appropriate training, real-time monitoring after officially launched, and continuous optimization algorithms. And the last one should be the maintenance and improvement. It includes the routine maintenance, performance analysis, and system upgrades, scalability planning, and stakeholder feedback and communication. I think following this complete map of the work plan, utilities could ensure maybe a successful design, installation, operation, and maintenance of the VPP.
So what can either engineers or the designers inside the utilities do to help increase, VPP usage or to get one started or specifically like if they're going to build one, I mean, someone's got to design it so that it works. What might be some advice or even to the managers to get more of these going?
Engineers working for or with the utilities can improve VPP usage by focusing on technical improvement, development and improvement, operational management, stakeholder collaboration, regulatory compliance, research and education. Their roles can be design robust VPP architectures and systems that efficiently integrate different DERs, ensuring the interoperability across different components of DERs, optimizing the operations of utilities by design, and managing the demand and response programs, engaging the stakeholders, and staying at the cutting edge of the technology and the innovation. These efforts from engineers could collectively contribute to a wider usage of VPP.